Okay, so we have our particles emitted. Maybe let's increase the speed a bit. So we're setting the speed here, but to make it simple, let me just use combine X and just use -0.01, connect it here, so that if I want to increase the speed, I can just use a vector math here, set it to scale, and let's say maybe double the speed. Oh, this should be 0.1 on point. Okay, that's too fast. Let's do 10. Now you might notice that when we increase the speed, we get some breakup patterns like this, and now our collider doesn't seem to work anymore. And the reason for that is that when these particles hit, because the speed is really fast, they seem to go out sometimes. Let's bring back our collider here, join it back in after the collision or after the simulation, so that we can take a look at. You can see that some are going through it, and to make the collider easier to see, I'm just going to convert it to curve, mesh to curve, so that we see the wireframe of it. Yeah, so some are colliding with it, some are not, and one of the reasons why that could be happening is because when they have a color of white, it means that they have collided with the mesh. When they turn back to black, then this set position no longer works on them, so they can go through the mesh. What I'm going to do is instead just store an attribute called hit or collision. Let's use store named attribute. It's going to be a boolean, and what it's going to do is store the hit value. So whenever the particle hits the collider, we're going to keep track of that. So this is going to be a boolean value, and it's going to be called hit. Now the value is going to be this, and let me first remove everything here. So you can see that, let's see, we don't have to set this value yet. If I take a look at the named attribute hit, take a look at that, you can see that this is registering when these points hit the object, and it's not missing any. But when these pass through, the hit value changes back to black. But we want it to be consistent, so all you have to do is just use the math node and add the hit attribute to this hit value before you connect this, before you store the value. So what it's going to do is this store named attribute on the first frame creates the hit attribute with a value of 0, so no particles are hit, and it's going to store that value until some particles are hit. So when those particles are hit or collide, that value is going to be set to 1. It's never going to go back to 0 after they hit, because they start out with a value of 0. When they hit, whatever this value is added to the hit value. So this value is always going to go to count up, giving us a white value instead of a black value. So all the particles after they hit, they're going to stay white. Some here missed here because they didn't collide, which is also a nice demonstration. Now this hit value can be used as the set position, and this position now can be used as the positions. Now if we take a look at this, let me remove these notes here. Now you can see that this is colliding, and I'm just going to let me grab the collider and move it directly in the way. And take a look at this. Perfect. So that's great. Let's remove this stepping effect we are seeing here, and maybe even bring back our hand. So I'm just going to join this here so that we can see the hand emitting the particles just like that. You can see how, because these particles are moving really fast, they're creating stepping here. We don't have enough steps here. So what I'm going to do is randomize this value here. So let me just do this. We can multiply this vector by some random value. So I can add a scale value here and use a random attribute. Just randomize that, and that should break up that. Let's do 0.5. Let's do 1 and 0.9 maybe. Maybe 5. Yeah, so that breaks up that really easily. And take a look at that. We have some waves. We can increase the turbulence a bit. And yeah, we have some nice particles. Let's take a look at this in the render. So I'm going to just set up some materials. Let's make the world dark. And here we're going to do a set material for the particles. Let me call this part 2. So this is set material. And that material is going to be, let's call it lights, and bring it in here. Take a look at that. So we can go to the shader editor and use, to set up these lights, you can see that in some areas where the particles overlap each other, where the particles are many, we get a lot of light. So let's emulate that by using an emission shader and a transparency shader. This is very, very simple. And because of the transparency, when the particles are spread apart, they're going to be less light. And when the particles are tied together, like say, or are clamped together, like say here, we get really, really, we get a lot of light. So I'm just going to mix these together. Take a look at that. And we need the transparency to be very high, maybe 0.1. And you can already see that in areas where we have a lot of particles, we have a lot of emission. And let's change the color, maybe something like that. Let's do, yeah, so you can see what we have. In fact, we might even want to do a quick render here. So I'm using Eevee. We can even add ray tracing if you want. And the great thing about this, what we have done here is, since we used a collection, I can even bring in a ground. Let me go to my asset library. I think I have some scanned ground, something like this. Bring it down. If I look at the mesh, this mesh here, it's too subdivided. It has a lot of polygons. So if you import that into geometry nodes, you're going to slow down. It's going to be heavy for the simulation, and we want a really optimized simulation. So instead of using this directly as my collider, I can just have it there and just create a mesh like this. Let me subdivide it a few times, just like that, and use the shrink wrap modifier and use the object as the wrap and use a projection so that this is projected onto the ground. I can even add some offset so that this is not directly onto the ground. I'll shade smooth, just like that. And now this, since this covers the ground, but you can see that it doesn't use a lot of subdivisions, I can use this as my collider. And in fact, I can just dump it into the collider and it will be used as my collider. Let me hide this for a second. And now if the particles hit this, they'll also take on the position. Yeah, so now the particles that are colliding with the ground are also taking on the position of the ground. You can switch out any colliders you want. If you don't want these particles to go, for example, you don't want them to go under the shield, what you can do is just mask out this area, maybe using some Boolean. So this is where this our original collider. Let's go to our original collider. You can maybe even just select this. Let's go to the collider here. I don't want any particles to collide with this. So let me just set up a vertex group, call it remove, assign, and now I can hide this. Now in the simulation, so this is our collider. Okay, in fact, we can even take a look at that. Since we have created a vertex group, I can just use the delete and use the vertex group we have created, which was remove, to delete that part, those parts, and now we can use this as the new collider. And you can see that the particles will now take a different route. Let me change this to faces. And yeah, our shield also has to be cut off so that it doesn't intersect, because it makes particles go under instead of around. So you can also do that and just go to the collider and make sure that the shield doesn't go all the way down. Perfect. We can turn on ray tracing, but you can see the particles are not adding any light to the scene. If you're using cycles, they would be able to do that. So the trick I did was I added a light, an area light facing the direction of the particles. You can use a point light, but the point light will also bleed some light in the back. I just wanted the light to follow the direction of the particles. So instead, let's use a point light like that. And we already have the particles. Let's add some space here. But you don't want each particle to have a light. In fact, if you do that, Blender will likely crash because lights can significantly slow down Blender. So what I'm going to do is use a delayed geometry, delayed point, and delayed by probability. So using the random value, set this to Boolean, which will give us the probability. And we want to delete nearly 99%. So we remain with, let's see, 264 points in this case, but that's also too much. So I'm also going to further delete by randomly from that 200 and whatever. And you can do that by simply using the Boolean math. So if you change this to O, it basically means that whatever this deletes, delete more again using this random value. And what you have to do is make sure that the seed is different so that this gives you a different random value. So if I change this to 1, you can see that we have gone from 264 to 9 points. So that's enough lights. Or if you want less, you can reduce this value and you get about 60. But let's do maybe 10 points. So 9 is okay. So now I can instance those lights onto these points using the instance on points. And I can bring in that light. And it has to be an instance. So make sure you mark as instance and pick instance. So if you take a look at this, we should get the lights. They're all facing down. So I'm going to use relative so that they are facing the object. But you need to, if you do that, you need to make sure that you clear the position of the light. And to make sure that this doesn't render, I'm going to just use another collection called lights. Just disable that so that we don't see it. I can reduce the scale if I want. And now we have light. Now we can join this to the rest of the geometry. So we get something like that. I think, let's see. Yeah, when they are very low like this, you get some harsh light. So maybe you could change this to a point. Yeah, that could also be good. Let's go back to this. Now we can increase. Let's maybe add a little bit more. So right now we have 24 lights. Remember, the more particles you have, the more lights you're going to have in the scene as well. So you can see now we have some decent lights. Let me just add a little bit more. And all you have to do is change the color of the light to match your particle lights or particle colors, and we get something that looks interesting. I can increase the intensity of the light. So that's how you get the particles. Let me do a quick render before we go to the next part of this. And I can turn on motion blur. Usually, if you set it to end frame, you get better motion blur with Eevee. Now let's reduce the motion blur a bit, and I think I'm going to render about 100 frames and come back. Take a look at that. It's going to add a bake there, and it's going to be set to animation. Now before I bake, let me change this, increase the particle count to 1000 and bake.